Hi class, so today we're going to talk about solving radical equations. So this is section 9.7. So concept 1, we just want to talk about solutions to radical equations. So an equation with one or more radicals containing a variable is called a radical equation, right? So if you have an equation that has a radical, it's a radical equation essentially, right? So then some steps for solving a radical equation. What you want to do is isolate the radical, right? So get the radical by itself. And then if an equation has more than one radical, you just pick one, right? And then what you're going to do is raise each side of the equation to a power equal to the index of the radical, right? So the radical that you get by itself, you can raise it to that power, and then you essentially are getting rid of one of the radicals, and then you can keep repeating that process until until you get rid of all the radicals, right? And then step 3 is you're going to solve the resulting equation, and then lastly, you want to check the potential solutions in the original equation, right? And just a note here, right, this asterisk with number 4 is that really we only have to be worried about those that have an even power, right? So if you end up raising both sides to an even power, that's where we can get what are called extraneous solutions. In other words, they're kind of like extra solutions that don't actually fit the original equation, right? Um, so some things just to recall really quick. So we want to recall that if I have the nth root of a and this whole thing raised to the nth power, that the n's kind of like cancel each other out and we're left with just a, right? Because those are like inverse operations. And of course, this is provided that the nth root of a is a real number. Right. So just like a quick example, if I have something like the square root of x equals -5, right, then what I can do is square both sides, right? So if this becomes the square root of x quantity squared equals -5 squared, right? So squaring both sides, and then this gives me essentially that I have just x equals 25, right? Because the left-hand side squared is just x. Those inverse things cancel each other out, and then -5 squared is 25. So this is a potential solution. So we need to do, is plug it into our original equation and see if it works, right? So if I take the square root of 25, does this equal -5, right, is the question. So what we end up getting is 5 equals -5, which is false, right? That is not true. So this is an extraneous solution, right? It's a solution that worked through our methods, but it doesn't actually fit the original equation that we had. And kind of a key picture here is that, remember, if I take the square root of x, this has to be bigger than or equal to 0, right? It can't be negative. And that's true with any even index, right? So if you have an index of 2, 4, 6, 8, 10, so forth, that needs to be a positive or equal to 0. So that should be an indicator that that equation is not going to have a solution, right? So for this, we would actually say that there's no solution, right? We got one potential solution, but that one didn't work, right? So there ends up being no solutions, right? So now I have some examples. So that's kind of like the theory for this lesson. So now we just have some examples to practice this skill. So example 1, we're solving the equation square root of x minus 3 equals 2. Right? So what we want to do is add 3 to both sides, right? We're trying to isolate and get the square root by itself. So these cancel out. We're left with radical x equals 5, right? And then, the index here is 2, right? It's just not written. So what I need to do is take both sides of that power, right? So then that gives me x equals 25, right? 5 squared is 25. So then now what I want to do is check this to see if it works. So if I take the square root of 25 and I subtract 3 from it, does this equal 2, right? And I'll put a question mark above because we're checking to see if that's equal. So square root of 5 is 5. Square root of 25 is 5, so this would be 5 minus 3 equals 2, and 5 minus 3 is 2. So this checks out, this works, right? So the solution set is, x equals the set of 25, right? Where, of course, up here, the solution set would be the empty set, right? There's nothing that would work. Right? So example 2 is similar, except my index is 3 now. So we want to do the same thing. We want to isolate the radical part, right? So I want to isolate this part that I put in a box, right? So we have the cubed root of t plus 2 plus 5 equals 3. So I'd want to subtract 5 from both sides, and we get the third root of t plus 2 equals negative 2. Right? And immediately you should be thinking that we have a radical equal to a negative number, but that's okay, right? Because the index is odd, right? Remember, odd powers, can give you a negative result, right? Like if I take, negative 1 cubed, that's negative 1 times negative 1 times negative 1. So these two become positive 1, right? So this gives me 1 times negative 1, and then that, of course, is negative 1, right? So I can have a negative base raised to an odd power and get a negative answer, right? But if I took, like negative 1 to the 4th power, that would be positive 1, right? So every time you do an even power, you're going to have an even number of negative signs, so that makes everything positive, right? So just like a quick kind of refresher of that. So this is okay, right? So then the next step would be to cube both sides. So the cube is going to basically cancel out that radical, right? The cube root. So this gives me t plus 2, right? Just the radicand on the left side. And then on the right-hand side, negative 2 cubed is negative 8, right? So then I can subtract 2 from both sides, and I get t equals negative 10, right? So since this is an odd index, I don't have to check to see if the solution works or not necessarily, but it doesn't hurt to check, right? So, if we have the cubed root of t, which we're saying is negative 10 plus 2 plus 5, does that equal 3? So this would be the cubed root of, so negative 10 plus 2 is negative 8, plus 5 equals 3. So the cubed root of negative 8 is negative 2. So negative 2 plus 5 is negative 3. Or excuse me, negative 2 plus 5 is positive 3. So that checks out, right? So in other words, my solution set is t equals the set of negative 10. All right, so example 3, you'll notice that we have a rational exponent instead of a root, right? But that shouldn't worry you, right? Because what I can do is just rewrite that. So this would be 3 equals 6 plus, and then a 1/4 power would be the 4th root of x minus 1, right? So just using the idea of rational exponents. So then we can do the same thing. I can subtract 6 from both sides, which gives me negative 3 equals the 4th root of x minus 1, right? And immediately, you should be able to know that this doesn't have a solution, right? Because I have an even index, and over here I have a negative answer for that 4th root, right? So we could keep going and, get a possible solution, right? Like if I, take both things to the 4th power, we would get, 81 equals x minus 1, and then add 1 to both sides, and I get 82 equals x. So then if I try that solution, 3 equals 6 plus the 4th root of 82 minus 1, right, this would give me 3 equals 6 plus the 4th root of 81. The 4th root of 81 is 3. So I get 3 equals 6 plus 3. 6 plus 3 is 9, and those aren't equal, right? So, I could tell that there's no solution from this point, but if we keep going and plug it in, we only get one potential solution, and that one doesn't check out, so there's no solution, right? In other words, the solution set is the empty set, right? Remember, we can also show that with a null value, which is a 0 with a slash through it. Yep. All right, so example 4. Right, we have 2 times the square root of m plus 3 minus m equals 3. Right? So one thing you want to be clear about is this 2 in front is a factor, right? It's not an index. And also something you want to be careful with is this part is not under the square root, right? So when you're writing that and working with these, you want to be extra cautious with that. So remember, the first thing I want to do is isolate the square root, right? So I could add m to both sides, and I get 2 times the square root of m plus 3 equals m plus 3, and then divide both sides by 2, and I get the square root of m plus 3 equals m plus 3 over 2. And then now that I have the square root isolated, now is where I want to square both sides, right? So this would be this would, on the left side, would just be m plus 3, and this would equal, so remember we have to take each part to the power, right? So if you have a fraction raised to a power, you take the numerator to that power and then the denominator to that power, right? So this becomes m plus 3 quantities, m plus 3 times m plus 3, all divided by 4, right? Which this is going to give you, m squared. Oops. Well, we're going to have m plus 3 on the left-hand side still. Let me switch colors maybe so we don't run this together. So we'd have m plus 3 equals m squared plus 6m plus 9, right? So you have to FOIL that top, and then this would be all over 4. And then what we could do next is multiply both sides by 4. So that gives me, so distribute the 4 through. So 4 times m is 4m. And then 4 times 3 is 12. And then, these 4's cancel out. And what we're left with is m squared plus 6m plus 9. And then we would notice this is a quadratic type of equation, so I want to set it equal to 0. So subtract 4m and subtract 12 from both sides. So what we get is 0 equals m squared plus 2m minus 3. And then I would try by factoring this first, like we've done. And this will work out if I do plus 3 minus 1, right? So then remember what that tells me using the zero factor theorem. This would be m plus 3 has to equal 0, or m minus 1 equals 0. So then I solve each of these for m. So m equals negative 3, or m is going to equal 1. Right? So then I would want to check both of these solutions. Right? So, you take negative 3 and plug it into the original equation here and see if you get an equivalent expression, right? And then also do the same thing with 1, and they both, if they both work, then we're good, right? So I'll let you check those on your own, but they do both work. So in other words, the solution set would be m equals negative 3 and 1. Right, so that's the answer that we're after. Right, so now what we want to look at in concept 3 is what happens if we have more than one radical, right? So remember, the idea is you're just going to pick one radical, isolate it, and then take everything to that index, right? But if we look at example 5, this one's kind of nice because we have a radical equals a radical, and notice that both radicals have the same index. So they're basically both isolated already. And then so if I just pick the left one, right, I would take both sides to the 5th power. But what that's going to happen is just get rid of the roots completely. So this would be 2y minus 1 equals 10y plus 3. Right? So we want to solve for y now, right? So this is just like a normal basic equation that you've done lots of times. So we could subtract 2y from both sides. And subtract 3 from both sides. So on the left-hand side, we get negative 4. On the right-hand side, this cancels, so we get 8y. And then divide both sides by 8. So I'm getting y equals negative 1/2. right? And we have an odd index, so we don't have to be concerned about the extraneous solution, right? But you can check that still. I'll leave that up to you, but it does turn out that the solution set is -1/2, right? Y equals -1/2. Right? All right, so I have another one to try. All right, so the next two are pretty involved in terms of how much is written. With writing as big as I do on the screen, I might not have enough room to write on the paper. So I think what I'm going to do is just come off to the side and write these, right? But you can write them on your paper. I made them fit just fine on my paper, but I want to be able to write big enough so you're able to see everything I'm doing. Right, so let me just rewrite these. So example 6, we're trying to solve, we have 3c plus 1, right, the square root of 3c plus 1 minus the square root of c minus 1 equals 2. Right, that's what we're trying to solve. So we want to isolate one of the square roots, right? So maybe I'll just isolate this one here. Right, so I could add the square root of c minus 1 to both sides. So then what we're left with is the square root of 3c plus 1 equals 2 plus the square root of c minus 1. And then now, since I have that isolated, I'm going to want to take the square root of both sides. So on the left, I would just get 3c plus 1, right, because the square root and the square cancel out. And then on the right-hand side, this is 2 plus the square root of c minus 1 times 2 plus the square root of c minus 1. Right, so I need to FOIL this. Right, so if I take, 2 times 2, that gives me just 4. And then 2 times the square root of c minus 1 would be plus 2 times the square root of c minus 1. And then when I multiply these together, I get the same thing, plus 2 times the square root of c minus 1. And then multiply these two, the last, that would essentially be radical c minus 1 quantity squared, right? So then what I get is 3c plus 1 equals 4 plus, and then this would give me 4 times the square root of c minus 1, right? Because these two guys are like radicals, like terms, so 2 plus 2 is 4. And then lastly, the square root of c minus 1 quantity squared is just c minus 1, right? So we can clean this up a little bit. This would be 3c plus 1 equals, so 4 minus 1 is 3, right? So adding these two terms together, here and here. And then I would have plus c plus 4 times the square root of c minus 1, right? So just adding like terms, trying to simplify the right-hand side. And then now what we need to do is to isolate the square root, right? So we want to isolate this guy. So first, I would want to subtract 3 from both sides and subtract c. So what I get is 2c minus 2 equals 4 times the square root of c minus 1. And then now we could divide both sides by 4. And I get, this would be 2c divided by 4 minus 2 divided by 4 equals the square root of c minus 1. Which this could be reduced to be basically 1/2 c minus 1/2 equals the square root of c minus 1. So now the same kind of idea applies. I want to get rid of this square root so I can square both sides. So this left-hand side is 1/2 c minus 1/2 times 1/2 c minus 1/2, right? The exponent of 2 means I multiply it twice. And squaring a square root, it just cancels that out. So we get c minus 1 on the right-hand side. So I need to FOIL this. So 1/2 times c gives me 1/4 c squared. And then 1/2 c times 1/2 would be minus 1/4 c. And then negative 1/2 times 1/2 c would be minus 1/4 c. And then lastly, 1/2 times 1/2, this would be positive, right? Because negative times negative is positive, 1/4. So this gives me 1/4 c squared minus, and then a fourth minus a fourth is 2/4, so it's a half, so minus a half c, and then plus a fourth, and these were both equal to c minus 1, right, on the right hand side, just leaving that alone. So then now I need to solve for c, right, and this looks like a quadratic. So immediately having these fractions out in front, or maybe, I don't know, not necessarily confusing, but it'd be a little easier if they weren't there. So a technique that we can do is multiply both sides by the LCD, which is 4. So what this would give me is c squared minus, so if I take 4 times a half, that's 2, so it'd be 2c, and then 4 times a fourth would be plus 1, equals, and then I distribute the 4 on this side as well, so that would be 4c minus 4, right? So I need to distribute the 4 through to everything, and we get that. So that's just a little nicer to work with. And then I want to set this equal to 0, so subtract 4c from both sides and add 4 to both sides. So what we get is c squared minus 6c plus 5 equals 0. And then this, I believe, factors. Let's try. Let's see, so we'd have minus 5 minus 1, right? So then, using the zero factor theorem, we'd have c minus 5 equals 0, or c minus 1 equals 0. So if I solve both of these, we get c equals 5, or c equals 1. Right, and remember, these are potential solutions. Because if we look up here, I took, the powers I used were even, right? We were squaring things. So it's possible that neither of these solutions work, one of them work, or they both work, right? And the way to figure that out is we have to plug them in, check solution, right? So I'll leave that for you, and I wrote that out in the notes if you want to double check that. But they end up both working. So the solution set is c equals the set of 5 and 1, right? But don't forget to do this last step of checking, because you want to make sure that you don't have an extraneous solution like we talked about, right? So now I think we're ready to do example 7. So example 7, we have the square root of 4x minus 3 equals 2 minus the square root of 4x plus 1. So I already have a square root isolated, so I can just square both sides, right? And on the left-hand side, the square root is going to cancel out with the square, right? So what we're left with is 4x minus 3. And then on the right-hand side, don't forget that I have to FOIL this. Right? So we would have 4x minus 3 equals, and then 2 times 2, which is 4, and then 2 times negative square root of 4x plus 1 would be minus 2 square root of 4x plus 1. And then I get the same thing again from those two, so minus 2 square root of 4x plus 1. And then lastly, multiplying the last two together gives me plus, because negative times negative is positive, and then we have the square root of 4x plus 1 quantity squared. So this gets me 4x minus 3 equals, and then we'd have 4 minus 4 square root of 4x plus 1 plus, and then here this the squaring of the square root, they're going to cancel out, so I'm left with 4x plus 1. Right. So now, again, the idea is I still have a radical, so I want to get the other radical isolated by itself. So let me clean up this right-hand side a little bit. So 4 plus 1 is 5, right? So I can combine this term and this term together. And then we have plus 4x, and then minus 4 square root of 4x plus 1, right? And then on this side I have 4x minus 3. So then I can subtract 5 from both sides, subtract 4x from both sides. Whoops, 4x. So those are gone, that's gone. What I'm left with on the right-hand side is negative 4 times the square root of 4x plus 1. And on the left-hand side, those cancel, so I'm left with negative 8. Right? And then now I can divide both sides by negative 4. So we get positive 2 equals the square root of 4x plus 1. So then if I square both sides, I get 4 equals 4x plus 1, right? Because the square root and the square cancel. So then I could subtract 1 from both sides, and I get 3 equals 4x, and then divide both sides by 4, and I get x equals 3/4. Right? And remember, that's a potential solution, so we can check that really quick. So I had you check quite a few on your own, so let's do this one together. So remember, the original equation is the square root of 4x minus 3 equals 2 minus the square root of 4x plus 1. So we're checking if x equals 3/4. All right, so I just need to plug this in for x. Right? So when I take like 4 times 3/4, I get just 3, right? Because those 4s basically cancel each other out, right? There and there. So this becomes the square root of 3 minus 3 equals 2 minus the square root of 3 plus 1. So this would be the square root of 0 equals 2 minus the square root of 4. Square root of 0 is 0. And the square root of 4 is 2. So 2 minus 2 is 0, right? So this checks out. So the solution set is x equals the set of 3/4. Right? So there's just one solution for that, right? All right. So that's number 6 and 7. So those are probably the harder two, some of the harder two problems in the notes. So now we're ready for concept 4, which is applications of radical equations and functions. So we have some applied like word problems to work through these skills. So we have example 8. So this is the length of the legs S of an isosceles right triangle is S equals the square root of 2a, where a is the area. If the legs of the triangle are 9 inches, find the area. Right? So really, to do this, you don't necessarily have to really remember what an isosceles right triangle is, since you're given the equation and basically you're given S and you're trying to solve for A, right? So really, it's not super imperative that you know isosceles right triangle, but just so you remember, an isosceles triangle is a triangle that has at least 2 equivalent sides, and a right triangle is a triangle that has a right angle, right? So essentially, you're going to have a right triangle where this side, S, is the same length as this side, S, right? And then if we have this setup, we're told that the area is equal to, the side length is equal to the square root of 2a. Right? So that's what we're working with. So we know that S equals 9 inches. We want to find what a is. So if I plug this in, we would have 9 equals the square root of 2a. So to solve this, the square root's already isolated, so I could square both sides, and I get 81 equals 2a. And then I could divide both sides by 2, and I get 40.5 equals a. Right? So since I took this to a even power, I need to check this. So if I plug this into the original equation, I would have 9 equals the square root of 2a. So I'm just plugging in 40.5 in for a. So 40.5 times 2 is 81. So this would be 9 equals the square root of 81, which is true, right? The square root of 81 equals 9. So that works out. So the solution is that the area is 40.5 square inches. Right? So not too bad. And then the next one, we have a function that has a radical in it. So it says when an object is dropped from a height of 64 feet, the time t of x in seconds it takes to reach a height x in feet is given by, and then we have this equation. T of x equals 1/4 times the square root of 64 minus x. So part A says find the time to reach a height of 28 feet from the ground, right? So t is time. So in other words, what I'm trying to find here is what's t of 28, right? So this is just plugging in 28 into the function. So I would have 1/4 times the square root of 64 minus 28. So this would be 1/4 times the square root of, so 64 minus 28 is 36. And then the square root of 36 is 6. So this would be equal to 1/4 times 6, which this equals 6/4, which is equal to 3/2. So divide top and bottom by 2, which we can write that easily as a decimal as 1.5, right? 1.5. Right? So it takes 1.5 seconds. Right? So then part B is a little more involved. We're asked what is the height after 1 second, right? So in other words, we know t of x equals 1. We want to find x. So we have 1 equals the square root of, we have a 1/4 times the square root of 64 minus x. So remember, the first thing we want to do is isolate the square root. So I want to multiply both sides by 4. So that gives me 4 equals the square root of 64 minus x, right? Because the 1/4 times 4, they're going to cancel each other out. And then now I want to square both sides. So 4 squared is 16. And then squaring the other side just leaves me with what's under the radicand, right? Because the square root cancels with the square. And then now I'm just solving for x. So I can add x to both sides, subtract 16 from both sides. So that gives me x equals 48. So 64 minus 16 is 48. And since I squared, it's possible that's extraneous, so I need to check that. Original my equation was 1 equals 1/4 times the square root of 64 minus x. But the x value I'm plugging in is 48, right? So I can just write 48 here. So then I would have 1 equals 1/4 times the square root of, and then 64 minus 48 is 36. No, 64 minus 48 is not 36, it's 16, right? So then we have 1 equals 1/4 times 4, right? Because the square root of 16 is 4. So 1/4 times 4 is just 1. So this checks out, right? So the answer is 48 feet, right, for that one. All right. So make sure you're letting me know if you have questions, and I'll be happy to help. Thanks.